And get started. Our next session here is going to be led by Carl Kesselman, co-founder of Globus project with Ian and Steve Tiki. And helping him will be Kyle Chard. They've been working on the next iteration of services under the Globus Online umbrella. Ian briefly mentioned it this morning, sort of dataset management. So I'll let Carl take it away.
All right, let's see. Oh, I'm unmuted. Cool. All right, so this is, I guess this is being advertised as a preview session. So what you're going to hear is kind of some late-breaking work that's been going on. So in full disclosure, this is all still in the process of being baked. So this represents kind of current thinking. There's nothing here that you can kind of run off and start using tomorrow. So that's the disclosure. Certainly, I think part of what we would be very interested in is getting feedback and thoughts about what you hear and suggestions. So with that, I've changed the name of this talk a little bit, and I'm going to be focusing on this notion of dataset services, which again Ian mentioned this morning. And I've taken out the word metadata, but you'll see hopefully as we go through this brief introduction before we get into the demo why I've done that. Because what we're really trying to get across here is, in some sense, a much more transformational approach to how we're talking about managing and interacting with data in Globus Online. So I think a good way to start this conversation is to take a step back and think about how is it that we actually use data. I mean, so currently in Globus Online, of course, you have the Globus transfer, so presuming an underlying assumption in that is that, well, one of the things I want to do with data is move it around, right? So we'd like to take a step back and think, well, why do I want to move it around? What am I doing with it when I've moved it? What are the overall kind of scientific process or research process that I engage with data? What is it that I'm trying to do? And so if we try to take that step back, we can make a couple of observations. So the first observation that we're going to make is that researchers and research processes often don't involve, here's a single piece of data sitting in a single file, and I'm going to analyze that one file, and I'm going to keep on looking at that, and that's the end of the story, right? So invariably, what we end up doing when we interact with data and use data in the context of doing scientific discovery or research is it involves using multiple pieces of data go into answering whatever the question you happen to be answering is. Now, once we introduce the idea that, well, we're really dealing with lots of different pieces of data, the next thing that obviously comes up with that is, well, what is that data and where is that data? And the other thing that we see is quite frequently we're dealing not with one just consistent piece of data split across multiple files, for example, but we often have many different types of data which we need to connect together in order to accomplish whatever our scientific, the next step in our scientific investigation is going to be. And so we're going to see lots of different types of data, and it's going to be in lots of different types and formats of files. So in practice, what we see is, this whole zoo of file formats and file structures. We see a lot of Excel. We see a lot of raw text files. We see formatted files and structured files like CDF and HDF. We see kind of specialized discipline or domain-specific file formats like in medical imaging, DICOM format files, or VCF files in genomic processing. So we see these lots of different types of files, often which we need to combine together in order to answer a question. And the next logical thing that happens is once we've got multiple files of different types, it's more often than not, they're going to live in different places. So they're going to be spread across multiple locations. In the vernacular, they're going to live in lots of different Globus Online endpoints. So that's kind of the reality of the life that you've got. And of course, you've got a lot of ad hoc file formats, just arbitrary stuff stuffed into files of various types. The other thing we see as we interact with data is the exact subsets and groupings that we want to interact with are going to vary depending on what stage of the scientific process we're in, right, and what we're trying to accomplish. So if we're looking at genomic data, well, we might want to take a cross-cut of a particular individual and look at a phenotype and a genotype and imaging data on a per individual basis. Or maybe we want to do some cross-cutting image analysis, in which case we just want the imaging files across all the individuals. So we're going to want to be able to restructure, reorganize the data as we go, depending on what we're doing. And so one corollary that comes from this is what would be really convenient and helpful as we're interacting with our data, right, to discover new things, to do research, is not to think of it in its elemental units. Oh, here's an image file here, here's a file with phenotype data there, here's an Excel spreadsheet there, but to somehow glue it all together so we can manipulate it in the way we think about it, right? Here's this unit of things that are all related because I need them to do something. And then to interact with them at that level, where that interaction could be sharing it, it could be processing it, it could be copying it, and so on. So that's what started us, down this path. And what we observed, kind of, amplifying Ian's comments this morning about trying to make things simple for those who can't afford or don't have the ability or the manpower or the expertise to build complex data organizational structures. What we find is just keeping track and organizing the data ends up being hard. So how do we tend to do it now? What's kind of the best practice? Well, the reality is, if we're lucky, some projects are very organized and they have catalogs and data librarians and full-time people to deal with all this stuff. What we, most cases, end up doing is we take our data, we take a best guess at how we're going to use it, and we organize it into directories where we come up with some naming convention that we use for the directory structure and some naming convention for the file names. Now, if we've organized our data around these directory structures with these naming conventions, then things like Globus Transfer can help us out. So now at least we can manipulate a whole directory with 100,000 files in it, as a single unit. But heaven help you if you decided that you need to reorganize those 100,000 files and give them all a different name. I'm sure you've all tried doing that, or creating shell scripts that do symlinks that now reorganize everything and the symlinks are broken. And I'm sure we've all been here and done that, and we know it doesn't work very well, right? So that's one half, and then the other half is we then capture the status of what we're doing with the data. We stick it in a spreadsheet and say, these are the files I've looked at. Or we have a README file that we put on the side, or we put a sticky note on our workstation or our laptop to keep track of what files we've looked at. I'm sure we've all done some variant of that. And again, what do you do if you want to hand it off to a student or a collaborator and you convey to them, oh, here's the list of the files I looked at, or you email it to them, right? So it's a pretty sad state of affairs, right? But that's really, if you look broadly at what goes on, that's the way things work. And so, to Ian's point this morning, looking around, say, well, why can't I have services that look like what I find in the commercial sector at home available when I do my scientific go into the office? We ask a similar question. Well, why can't we manage the data at the office the same way we do at home? So let me give you, an example. So this is iPhoto. We can come up with a million other examples. Here's a bunch of really spiffy pictures of cats. So I'm following the common meme about the internet is solely to support exchange of pictures of cats doing funny things, right? But if you think about, what can I do in iPhoto? I can organize around my cat. I can organize around pictures of cats that were, taken on a vacation, on my vacation to Italy versus my vacation to India. I can keep track of other people's cats. I can combine cats with pictures of my house, right? I've got all these ways I can manipulate these pictures. Do I go in and change the directories to restructure my pictures of cats and keep track of, what picture I've looked at, what I haven't? No, I don't do that. I have the ability to kind of dynamically create and keep track of and organize my photo collection. Well, why can't we do that with our data? So the answer is, well, we think you can. And that's the motivation for introducing this notion of datasets and a new dataset service in Globus Online that basically allows us to organize all our files about cats, or other things if you not completely fixated on cats. So what do we do when we, so what is the Globus Dataset service? So what we're going to do is a couple of basic things. We're going to provide a simple method that allows us to group files together, and this grouping is not going to be static. We're going to allow you to reorganize and regroup based on what you want to do with the data at the current stage in time. So it's going to be a logical grouping. It's going to allow us to organize and reorganize and search our data, discover which sets are interesting, and so on. Secondly, so we can really understand what's in our data set, we're going to have the ability to annotate our data with characteristics that reflect its content. So this is why this discussion of data sets subsumes the discussion about metadata, because now the ability to annotate our data sets is a core part of what we want to do. And what we want to do when we do this is capture as much information as we possibly can about the content. So if we have metadata about what we're including in a data set, we would like to use that. And we'll show you how we're doing this in this prototype data set service. Third is we want to be able to not only annotate around content, but annotate around use. I'd like to know, this is the data I need to look at next. This is the data I've already checked. These are the bad files, right? You'd like to be able to track that stuff that has to do with how you're using and interacting and collaborating around your data. Right? And then, once we aggregate these things into these logical assemblages, now this becomes a really convenient and easy way to talk about sharing and collaboration. Because now I'm not just exchanging, oh, here's a directory with some stuff in it. I'm exchanging, well, here's a set of stuff that's organized because I need you to do the following. And here's all the context you need in order to figure out what to do next. So it becomes a fundamental operation, a fundamental means of sharing. And then finally, what we want to do is raise the level of abstraction, so now we can define sets of operations or useful things to do that are targeted towards the data set, not these arbitrary sets of files. So things like copying or exporting or analyzing or put it into a workflow engine. So that's the basic idea of what we're doing. So what we've done is we've created a prototype dataset service, which now sits on top of the Globus Online services that you've already heard about, and is going to provide these types of operations that I just described. And we're augmenting the Globus Online services with a few new capabilities, mostly around the collection and management of these attributes, catalogs of attributes, and around how to extract information from data that exists within the Globus Online service. So I think at this point, we're going to switch to the example. It turns out there's a slide missing here, but that's okay. We'll deal with it in the demo. So let's switch over. We're going to show you a prototype data collection service that we've built on top of Globus Online and top of some of these other capabilities that I just described. So as I said, this is not ready for production use, but everything we're going to show you is real. This is all working. There's nothing funny going on under the covers here. So the example that we're going to use is going to be drawn from some a specific use case around genomic processing or genetics processing, and actually Ravi is going to pick up on this in more detail in his discussion, which is going to immediately follow. So I'm not going to go into great detail about the science here, but this comes from a researcher here, the Onell Lab. It's the processing or the data is driven around collecting genetic sequences, doing some comparisons against the human genome maps for looking for what's called rare variants. So these are kind of these infrequent kind of differences in what's going on in the genetic sequence. We're going to involve, we've taken a little liberty here. We're going to say we're going to have genetic material both from humans and animals. We're going to be looking at, in this case, three basic types of data. One is imaging data, which is stored using a standard imaging format called DICOM, which has It's a structured file format, so it has some metadata embedded in it. The second, the other one has to do with raw sequence data, and the third is these variants. The VCF contains the variants, and these also have some metadata in it, embedded because they're structured files. And in this case, we've also got some useful metadata that's actually embedded in the names of the files. So there's some naming conventions that go in here as well. So what we're going to do is show how, in this case, where we've got 3 different types of data in multiple locations, how we would use data sets to track and organize these things. So with that, I think, demonstration. So Kyle is going to drive, and I'm going to interrupt. And if there are any questions along the way, I think we can. Well, we're ready to go here. Okay, so we're going to start with the normal Globus Online login sequence. So, and I should get my notes so I make sure I don't forget anything. Thank you. So we're going to start with the normal Globus Online login. So take it away.
Yeah, so the first thing I should say, as Carl mentioned earlier, this is running in a separate instance of Globus Online, so you can't actually use it yet with your Globus Online credentials, but we've set up a parallel sort of infrastructure for it. So I'll just log in using my normal credentials.
Maybe.
Maybe I don't have a network connection.
Here's the part where I start to tap dance, right?
Use the filler.
So, all right. We're maybe logging in.
No, we're waiting for this to reload.
Okay. It's exciting, isn't it?
I should be wired anyway.
Okay, Ravi, you should be checking your connection now. You did, okay. Sure, go ahead. Let's take questions.
About a data set. For the one that you described, you've got the iPhoto. Apple has decided here are the things that are important about photos. It's GPS and keywords and things like that. And then there's the second set, which is using those, which is what you've done with your cats.
Yeah.
Which one of these have you done, or both?
Right.
Do you have the ability to create schema, or do you have a defined schema for genomics that you are using?
Hold that thought.
Okay.
So the answer is we've done both.
Okay.
And I'll tell you how in just a moment. All right. So what we've done here is we've logged into Globus Online, and now in this variant version, now we are now going to be concerned with data sets, not files. So forget files for the moment. We're going to think about the universe of data sets. So what we have listed here is now a set of, and these have been pre-created. We're going to show you how to create a data set in a moment. But these are data sets that have already been created. Notice they have dreadful names because this is the way the investigators think about this stuff. These are the names that make sense to them, not to you. You could use whatever name you want. But the name of the data set is almost irrelevant, and we can see why. Let's drill down into one of these data sets. Now, assuming the network is working, what we're now doing is looking inside of this data set abstraction. The first thing we're going to see here is kind of an overview of just some high-level details or attributes of this data set that have nothing really to do so much with the contents, but what we have here is the name of the data set. Each data set has a notion of owner, and we're going to get back to that in a moment, but I'll just tell you, we have fine-grained access control over all aspects of a data set, which allow us to now use this as a vehicle for collaboration. So we have the notion of an owner. I'm going to get back and talk about catalogs in just a moment, and I'll answer your question when I talk about that. And things like modification time. So now we can go, let's look at something interesting. What we see here are now a set of attributes, right, that are associated with the data set. Right? Now, some of these are actually predefined, and some of these, what we'll see is you can add your own as you go along. So the answer is yes, we do both. So here we see some attributes that were pulled out of the files from the metadata in the structured files, and we have some additional things that we just decided to add because we found them interesting. We can also control sharing. We'll get back to that in a moment, but this fully uses the new Globus sharing capabilities and actually adds to that. But then let's look at the last thing, which is kind of the most important part, is in this case we've associated all the files in this directory, in this case it's in the directory, of this particular Globus Online endpoint are now associated with this data set. But of course, data sets aren't just restricted to a directory. It could be arbitrary lists of files. It could be multiple directories. It could be directories from different endpoints. Those can all appear in here, and everything just works just fine with that. All right, so now we've seen, so let's go back to the top. Now we do have some, as I pointed out, these tags on the data sets. One of the things that lets us do is now discover which data sets are available that are interesting to me. And so we've got a little facet-based viewer here. So we're just going to select, let's find all of the data sets that are associated with humans. And now we have them. How did it do that? Because there was a tag associated with the data set which indicates this is coming from a human. Right? So now, and we can see we've got that element here listed, the organism is human on each.
So the other thing we wanted to talk about briefly as well was the catalog context. So at the moment you're seeing all of the data sets within my ONAL exome analysis catalog. So I can also change this to a catalog that's personal for me, or one that I've developed as part of my climate research or my APS research. If I have a look in one of these other ones, you'll see that I've got no data sets in there at the moment.
Right, so this notion of catalog allows us to organize things around disciplines or projects. So that's where we can define restrictions or predefine certain schemas. We can also do access control at that level. So that allows you to kind of capture community standards and get the right flexibility between how much stuff do I know and define up front versus how much stuff do I do on the fly. So here, right, we're looking at right, so we're back in the genomics catalog. All right, so that gives us, so we've seen data sets, we've seen catalogs, we've seen that you can put files inside of data sets, and we've seen that you can add attributes and search on those attributes. So now let's do something exciting. Let's create a new data set. So we'll pick some arbitrary name. We're going to pick a catalog, and again, this catalog is going to say what, are there predefined schema, or what's the access controls, things like that. So we're going to keep this in this exome. And now, the next thing we're going to do.
Yeah, so we've pre-populated a few Globus Online endpoints here. So this is a sort of widget that allows us to look at an endpoint using Globus Transfer to list the contents. So we've set up a couple of endpoints in preparation for this demo, one of them being a shared endpoint, which we'll come back to later, that lets us do different sharing actions of the actual files underlying the data set. So,
and we're going to drill down and just take a look. So in this case, as you can see, we've got the name of the subject or the experiment here is coded by convention in the directory name, right? But now if we drill down one more, what we'll see is we actually, for each one, we have 3 different types of files. In this case, we've organized them in directories because that's the way we got the experimental data. The DICOM, which is the imaging data, the VCF, which is the variant, and the FASTQ, which is the raw sequence data. So just to let you know what's going on here. Okay, so now, but we're going to pull this whole thing in. All right.
Yeah, so we've just added that single directory, the root of our data set. So we've associated that root with our data set. You'll see it here as a list. So this could span multiple endpoints, but at the moment we're only using one.
So now, the next thing, so this in some sense goes to your question, we can now, there's some implied tags and attributes in there because of the models we're using, but we can now add our own because, well, we want to start reflecting things that are useful to us, not things that are useful to the person who decided the file formats. So Kyle's going to add a couple of tags to this. And we have various types, 2 types of tags. We can just have tags which are have their names that we care about, but we can also do key value pairs as well. So we can add our tags. Now here's a cool thing, is that, as I mentioned earlier, what we'd really like to do is to extract as much metadata as we can, and we notice some of it is structured because it's in the DICOM file, some of it is not so structured because it's by naming convention. So what we have is a set of parsers that now are used as part of this process that are going to go through and not only look at the directory name and the path and the components of that to pull out things that I might have told it are useful, but then pull out standard fields that exist in these structured files. And this is a rule-driven system, so it's easily extensible. In this case, we've configured these parsers into this catalog because we know these are the types of data that you're going to be looking at. So here, we're picking the VCF parser, the DICOM parser, and the FastQ parser. And yeah. We actually are doing the parsing. We've added that functionality to the Globus Online endpoint. I'm sorry? Yeah, you can think of it as being in the Globus Connect.
It's running alongside the endpoint. It's not integrated at the moment, but it's a service running alongside the Globus Connect endpoint. And so the other thing is these parsers are because we're in this exome analysis catalog. If we were in a climate catalog, we would have parsers for NetCDF. For in an APS catalog, we'd have HDF5 parsers. So it's very context specific.
Right, and then there's also user-defined rules that we can create and add. If I've got this kind of weird thing where, oh, well, the first part of the file name is the name of the subject, the second part is the date that the thing was run on, and the third part was the site that collected the data, and it's separated by dashes, we can define rules that map all those into 3 separate tags.
All right, so we'll go ahead and create it.
We're going to create a data set. All right, so we're now running the parser on the Globus Online endpoint. We've got the list of all the stuff that's going on. We've now gone on and created in this catalog a new representation for this data set, and we've extracted all the tags, and we've stored that in as part of the data set. And
yeah, so we'll use the new tag to actually find it, because that should only result in that one data set.
Right, so what he did here is when we created the data set, we created a tag saying new to capture, here's a new data set. Now we can easily find that, and now that's what we got. And we're going to look at some tags in there, right?
Yeah, so this is a mixture of tags that both, so these 3 were the ones we added, the human, the SNP, and the new. This tag here was actually extracted from the directory name that Carl mentioned. The chromosomes were extracted from the VCF file. The patient name was extracted from the DICOM. Obviously, it's anonymized, so there is no patient name. So we can go ahead and change that.
Right, so what he's done here is he's now edited a tag. So now next time we go and look at this, it's got a different patient name in it rather than what was there before. And now this is stored as part of the data set. And now we can go about our business. We say, oh, well, let's create a new tag. And so now he's just creating a new tag and adding that to the data set.
So that one there, we're adding a new tag to the label tag that we saw before. So we're associating this validated label tag to our data set. We can also go ahead and create a new tag here that doesn't exist. So the score tag, you'll see on the left, it's not a facet that exists at the moment. We have a bunch of options when we create these tags of different types. So text tag is great if you want to do simple queries, but if you want to do things like range queries or Boolean queries, it'll be a little bit easier with a specific data type. So with a score, we'll pick integer. We also have the option of making multi-valued tags, so there doesn't need to be a one-to-one association between a name and a value. We can have a name and multiple values that we can then query over. So I'll create that one.
Yeah.
So how do you keep the catalog metadata consistent with updates to
We don't. Yeah, that's actually a very tricky point as to whether that's the right thing to do or the wrong thing to do. So the question is, these updates are purely done with respect to the catalog, so we don't push anything back automatically to the files. So, and one could argue that's the right thing to do. So this reflects our view of our use of the data, right? So if we've made corrections to the metadata, these right now are private to us. These represent our interpretation of, you know, what the update should be. And again, sorry, just to make this point, the data can live in multiple data sets, right? So it's not just one piece of data goes to one data set. I could take the exact same directory and create a completely different data set and go with a completely different direction with different annotations and tags on it. And they are, you know, completely separated.
So it's up to the user to keep the metadata consistent.
It's really very dependent on the use case. So we don't do anything automatic about pushing values back. That's correct.
All right, thanks.
So these new tags we created are now available with the data set, the validated label and the score down the bottom. We'll come back to them in a little bit. The next thing we want to show is, I think, associating more files with the data set. So here we created it initially with that sequence data. We can also browse another Globus Online endpoint and associate a file on our Go EP1 directory, and you'll see now that we've got a multi-endpoint data set, one of them containing the directory and one of them containing a file there. So we'll get rid of this because it's not really part of the data set though.
Right. So the locations and the contents of the data set can be anywhere, right? But we can still now treat it as this one integrated entity. So now we've got this data set, we've added some tags, we've reflected, oh, we've validated these things and added scores and so on. So now we want to say, hey, Ravi, here's a cool data set. Take a look at this, will you? So how do we go about doing that? So we have the ability now to share the data set. Now this is, in some sense, a superset of what you heard about this morning with Globus Share, right? So Globus Share gives me the ability to access the files. Now what I've got is I can now take this whole kind of aggregated view and share that, which consists of not only the data and the metadata, but also the files underneath it. So Kyle is now going to share this data set.
Yeah, so the sharing we can do with any Globus Online user. So I've used my Kyle2 user account to share with. We could also use a group here as a username. It's probably not the best naming there. And I'm going to pick the entire data set, as Kyle mentioned.
Right. So now he's sharing it just read-only with Kyle2, which is his evil twin. Right? So now what we've done is we've shared the data set aggregation as well as the underlying data, the contents for read-only. And now let's go look and see. He's going to log in as his evil twin.
So you'll see I am really logged in as my evil twin up the top here.
And now there's the data sets. Now he's got a lot of data sets, but let's just find, I was told, hey, look at the one I just validated. So we're looking at that, and it says, oh, well, let's find some other criteria. Let's find one with a score that's greater than 5. And there it is. That's the shared data set. And so now we can go in and look.
So the interesting thing here is that none of these tags are actually editable because we only shared read access with user Kyle2. These tags are just static. I can't actually touch them. I can't go and add new tags. I can't go and add to the actual files that are part of that data set. So I'll go back and just quickly change that.
Right. Now what we have is fine-grained access control on not only the data set, but we can do this at the attribute level as well. So we can say, here's certain tags you're allowed to change, here's tags you're not allowed to change. So we, on a per catalog basis, we can kind of create all kinds of different sharing scenarios. In this case, we're just doing the whole data set. So you can either read or write the whole data set, or you can, right, it's the whole data set. And now you can see, we can now modify any of the tags that were associated with this data set.
And we'll change one that was clearly wrong, the patient sex. The other thing is with sharing, as Kyle said, we can share read and write, so we don't share the delegated rights. The Kyle2 user can't come in and now choose new users to share this data set with. So the other thing is each data set in our data set management service here is actually represented as a unique resource. So it's uniquely identifiable with this link. So you could take this link and pass it around through an out-of-bound mechanism. You could email it or IM it to someone else, and they'd be able to access this data set without needing to go through the same search procedure I went through.
Right, so this is more than just a bunch of attribute values in the catalog. It's a real thing that we can interact and control with and pass around, just like any other resource in Globus Online. And then there's interfaces that allow you to interact with it through this URL. All right, so now, yeah. I'm sorry, yes.
So you have implemented the parser to look at the files and extract metadata. Have you considered to write parsers for typical data management systems, I don't know, iRods and such?
Not so much that. What we've done, and actually Rob Schuler in the back has done this, is we've created a framework. So there's a generic kind of framework for managing looking through files and running rules on the files to collect the data, right? And then we've implemented specific endpoints for that. So I'm just going to do a bunch of hand waving here. If other metadata systems had, interfaces that we could retrieve attributes from them, we could use this framework to pull those out and then map them into whatever the tag structure you want for your catalog. So that it's an extensible framework, so we could do that. We haven't, but it's really a general engine for walking over sets of files, extracting out kind of attributes and values from them, and mapping them into whatever name and value space is appropriate for your particular project.
And in principle, you could interface to another system. You
Yeah,
don't
yeah.
necessarily need to do the parsing of the
Yeah. I mean, and we plan on interfacing with other metadata catalogs. We haven't discussed iRod specifically, but conceptually that should work as well. Very hand wavy here, but the structure was built to accommodate that. Yeah.
A couple questions. First of all, can datasets contain datasets?
That's a question we're still debating on. We think the answer is yes.
I think technically it can be done. It's just what are the semantics around doing it?
Right,
Yeah.
because I could see that being really helpful in terms of, it actually touches on the next question I have, which is I assume that you guys are, again, making an API available for this that you can, because I could easily imagine it.
Yes.
Some sort of set of instruments coded up to each
Yeah,
generating their own. And
Yes. So yeah, we are developing a REST API for datasets, which is, the point is each dataset is a resource and has the URL, and there'll be an API around that. So the answer is yes.
Okay. And then under the sharing, is it possible to sort of redact files from the data set? Or, I mean, I know you've talked about the tags, but I was just wondering if it's possible to actually restrict file access as well.
That's an interesting question. We're still sorting out some of these design issues. There's certainly a design path where that would be possible. So,
Have you guys thought about, and this might not be the right abstraction, but is there the idea of having tags at the level of files?
yes.
So that you could build a data set of files, all files that have this tag?
Yeah, so we didn't go into that here, but yeah, that's part of it.
The
part of
model
the
actually supports that at the moment. It's just that we haven't found a nice way to expose it through the UI yet. So definitely, and I think that'll talk to your point as well about redacting access to single files. So I guess we should finish this off quickly. So
Yeah, why don't we finish this and we'll take your question. How about that?
So,
go
ahead,
ahead.
Carl.
Well, I was going to say, okay, so now we've created a data set, we've modified it, we've added files to it, we've shared it. Now let's do something with it. So we can define a whole kind of class of operations across it. And so this is a slightly different take on thinking about Globus Online. So right now when you think about Globus Online, the operation you have is transfer files from point A to point B. So we're going to hoist that up a little bit. And what we're going to think about is now classes of operations on data sets. So one of the things we might want to do is take this data set and get it on my laptop or my computer so I can run my favorite analysis program on it, which wants to see it sitting in a local file system somewhere. So what we're going to do is an operation we call export, right? And the goal of export, using Globus Transfer and Globus Endpoints and Globus Connect, all that stuff is there, right? But the way to think about this is I'm taking my data set, wherever it may be, whatever the contents are, and I'm going to stick it now on a local file system so I can run whatever programs I want on it. And we have the option of moving not only the data, but also the metadata. And the other thing we can do is we can do this is, and we're not going to show this here, but we can also do some reformatting. So for example, stick it in a zip file or restructure the directories, things like that. So Kyle's going to now export it.
So I'll go ahead and use Globus Online Transfer to transfer it to my Globus Connect running on my laptop. I'll pick a directory to dump this in.
Now this is regular Globus transfer, so you can monitor it with the standard ways of looking at it. You can track its progress. You can, all the normal things you'd expect to do, you can do.
The only difference is we're picking one endpoint, the destination, because the source may be more than one. So.
And there's now the transfer going on.
Yeah, so as Carl mentioned, we can go and look it up. Looks like it's already gone through at the time's right, 7 p.m. You can actually see if it went through as well on my...
This is actually doesn't need any additional services at all. This is just using Globus Connect, right? But we're driving it from the Dataset service is now driving the appropriate sets of Globus transfers. Yes. Right. So we're now adding verbs that are a little more semantically high level and make sense when we start thinking about what are the different things one does with a data set, right? So it could be copy, could be replicate, could be export, could be, so there'll be some expanding set of verbs that will be oriented towards data sets. And the underlying implementation, underneath the covers, it's still doing all the same stuff, but we've kind of elevated the level of discourse a bit. So now we're no longer thinking about, oh, I had 3 directories I needed to transfer. It says, here's a data set, move it. So, right, and we have here a set of other verbs like analyze. So you could, for example, imagine pushing this into the Galaxy, the pipeline processing Ravi's going to talk about next. So I think that's it. So let's just wrap up and then we'll take your question. So just a couple of points we want to make here is that what we're really trying to advocate here and putting forward is in some sense a paradigm shift as to how you think about data. Stop thinking about data as collections of directories and files for which I need to take what I actually want to do and figure out how to map that into these kind of physical layouts, but think more naturally in terms of what am I trying to do and what are the natural aggregations of data and how do I manipulate those or manage those as part of my work and annotate and integrate this into your work process. So it allows you to organize data in a way that makes sense for the way you do your job. It enhances the notion of sharing and collaboration because now I have a single, easy, convenient way of telling you to look at something which has a lot more context and detail in it. It's multiple directories, multiple sets of files, annotations, current state, what I've done. So it's a kind of an enhanced way to think about sharing. And this really now opens up high-power, very flexible data management capabilities to small labs. So people who would normally, or labs that would normally stick stuff in an Excel spreadsheet or those sticky notes on the side of your terminal because you can't afford to put up a database and build a catalog and come up with schema and all that stuff that maybe larger, longer living projects have, this is just there and you can use it. So it really, again, speaking to kind of Ian's point, makes these type of sophisticated capabilities available to a much broader base of users. And just pointing out, we had a lot of people contributed to this. So Rachna and Rob Schuler, who's sitting in the back, Carl Chakowski, who's not here, Bryce, who is sitting in the back, and Steve. And then, do we have time for that last question? We have time for your question.
I was looking at the different data types that you have. You've got these bools and floats and things like that. And what comes to mind is some of these other use cases that you described, like analyzing data or even redacting, might be enabled with a data type of a pointer to a data set. That you could have this data set or this file or this thing was derived from, for example, that thing.
Yeah,
and if you have pointers, well, all computer science problems may be solved by adding a level of indirection, right? So you might be able to do some interesting things with that.
Yeah, we've thought about that a bit, and the underlying framework that we're building this on is actually way too flexible, so there's pretty much nothing we can't do. So the real challenge that we've been wrestling with is how much detail to expose and how to present it to users that are not going to be overwhelming. But we have thought about those types of things as well.
Could you sketch a little bit about what a verb looks like, and will people be able to write their own verbs?
Good question. That we haven't thought about. I mean, the verbs we've thought about, you feel free to chime in, things like export, analyze, copy, replicate.
Analyze is a pretty big space.
Well, so analyze would be like pass it off to a pipeline like what Ravi is going to talk about.
I think the API buys us a lot here. So a lot of those things with published APIs can be written externally as more of a source rather than a sink.
I like that answer.
There was one more question? And then I guess we should stop.
I was just wondering, is the expectation that once a data set's created, it's sort of frozen in time? And if that's not the case, then if someone's accessed a data set, how would they know if there's been updates to it or other changes they might be interested in?
Right, so the idea is data sets are not frozen in time, that they're meant to be kind of living, evolving things. Now we're really in the more hand-wavy. We've done some experimentation with versioning, which is somewhat complicated, but we would like to have some kind of snapshotting and versioning on data sets. There's details to be worked out on that. So we understand that that's an issue. Yeah, well, so there's some issues as to what are the transactional boundaries going to be and so on. So we don't want to make it so restrictive you're not going to use this as a kind of a way of conducting dialogues with collaborators or with yourself. That's it. Well, thank you.
Great, thank you. Okay, next up we have